So, welcome to the tutorial on developing machine learning models as API services. This was born mostly out of my struggle in trying to integrate machine learning models into web applications. So, along with a friend of mine here, Morgan Smatson, we built a startup called Engine Room 360, where we are trying to use machine learning into a real-time shopping application. And after that, I went on to work at, do some projects at Insight, and then at 5 Stars, where I really got to understand Tornado as a web framework, and then that's primarily what I'll be using in these in this talk here. And then currently, I am doing part-time work at Medis, where I help teach, mentor data science. All right, so what's the problem? So problem is that we have a polyglot environment. We have data scientists who love Python, hopefully, and then Scikit-Learn, and love to build models from it. But you have a web team and web stack that might use Python, that might use Ruby or other languages. So we need a way to make machine learning models work with web applications. Okay? So that's the motivation for this talk. How do you make your machine learning models production ready? How do you make it work with web applications and not have to rewrite in a different language? So, okay, audience. So here is what I put down there as to, you have done some machine learning models. You have seen web apps. You don't have to have done any web apps for this particular tutorial. You have never deployed the model, okay? And you're ready for some hands-on tutorial, all right? So that's the expectation. So we'll talk through the architecture that I used and I like. So we will walk through pieces of it. How do you build an API service? How do we query the API service from a Jupyter notebook? And then we'll build a web app that queries the API service. And finally, we will deploy this API service into AWS EC2 machine and then query through our web app. And we'll try to do all of this in the next hour and a half. So this is the architecture that that's the motivation for this talk, where you have clients, coming to your web application, which could be Ruby, Python, or whatever, and then they have ways to reach resources, but there's no easy way to read your machine learning models. Machine learning models are not, cannot be opened by other applications. They need to be opened by within the same ecosystem that was built in. Okay. And we're going to make machine learning model accessible to the web app by wrapping it inside as a micro API service. Okay? And in this case, we're going to use Tornado as a web server for it. And later on, I'll tell you why Tornado is a good choice for this. Okay? At any point, if you have any questions, please stop me. I don't want to talk through these slides. I want to make sure that, if you have any questions, please address them. All the code, all of this is on GitHub, so we'll definitely, everything is, I put some notes on it, so don't feel, hesitation, to ask me questions. All right, so machine learning problems. I'm going to take a very simple machine learning problem, which is the famous iris data set that's integrated into Scikit-Learn. So it's a classification problem. You're trying to classify, given a petal and a sepal length and width, you're going to classify what type of flower that is. Okay, so you can see, based on the various values, you have some good training data, and we're going to use to build a prediction model for this, for this machine learning app. Okay, it's a very simple app, very simple machine learning model. And the reason it's a good model here is because it's got a really nice separation of data points. So you have all these by the petal length and sepal width. You can actually separate these flowers very easily. And because you can separate them very well, I'm actually going to go with a KNN model, a very simple, K nearest neighbors model, just trying to look at, who are the nearest neighbors to that, to each observation to identify which class of flower it should classify as. Okay? So the reason machine learning model is simple is because you want to actually work on how do you deploy these models. All right, so it's time to actually get hands-on. Okay, so we're going to build this machine learning model as an API service. You may not write any code, but you'll actually install pull down my Git repo, run it locally, and then we will walk through the code, what it does, and then hopefully then you can take it and apply it to your own machine learning problems. Okay, so that's actually the location for the Google Slides. You can pull that one as well if at any point you feel like you need to copy paste from the commands. So that's the Google Slides. That is YAT socks, Y-A-T socks. Okay. So we're going to run it through terminal. So open a terminal window, and we're actually going to work with 3 terminal windows. So we will have multiple tabs on a terminal window eventually. So right now we just need 1 terminal window. Okay. And it's quite possible that there are environments out here that I have not tried this before. Like I've tried it on one other machine just before this talk. So it's certainly going to be environments it's not going to work under very nicely. So I want to make sure that people can work in groups, help each other out. If you have done your step, please make sure that you can, you do reach out to your neighbor. All right. So this is what we're going to do in the first step. We're going to first build this API as a service. We're going to build this Tornado web server and wrap the Scikit-Learn pickled model. And then we're going to predict from that model and return that as a get and post API service. Okay, so prerequisite is you have Anaconda already installed on your machine. So, almost everybody has them. Don't be inside a virtual environment, because we will actually create a virtual environment, Conda environment, through this project. So don't run this inside a Conda virtual environment already. All right, so for this project, we're actually going to use another project called Cookie Cutter. Cookie Cutter is a very nice Python project that allows us to pull in templates and then use templates into creating our own apps. So if you can, open a terminal window, not in a virtual environment. And if I can also suggest, create a new folder, because we're going to pull in 2 different projects inside the folder. So don't do it directly under desktop. Just create a new folder in your terminal window. Make sure where you are, because we'll go back to terminal window a few times. And then do pip install Cookie Cutter. It's a very small package. It should install really quickly. And you should definitely check it out, the Cookie Cutter project repo. It's a really nice one for creating your own project templates when you want to share with other people, so that they don't have to start from scratch. All right? So if you have that, the next one, this is where having the slides on your screen is very useful, because you can actually copy and paste, but you can certainly type it in as well. So we're going to say Cookie Cutter, instead of, usually what you do is git clone this git repo, but we're not cloning this repo. We're actually creating a template from the repo, so that you can actually build your own projects from this repo. So do Cookie Cutter this URL. It'll ask you a series of questions. Okay, and it's only a couple of questions actually. It's only what is the name of the project you want. If you have done Django, Rails, it's basically the same thing. You'll say Django start or something like that, and then it'll ask you, what's the name of the project, where do you want to store it, and stuff like that. It's the same sort of questions, but only 2 or 3 questions, and then that will create the application for you. I have created default names for it, so that we all have the same folder names once it creates it. But if you feel like you should change it, feel free to change it. In the meantime, I'm actually going to go and do it myself as well, just so that I time it correctly. Clear. Let me exit my terminals. Exit. All right. Okay. Okay. I want to go into my temp folder. PyData tuts tutorial. Okay. Okay. Oops. It's nothing in the folder. I'm going to do the same command. Copy this. All right. So it's going to, I already had it installed, so it's going to, you will not have that question of yes and no. So it's going to create the repo. Hopefully the internet is still working. It should be working. Oops, it's offline. How do I do this? All right. I have no idea. I don't know, somehow my Wi-Fi has gone offline. I can't get to my top bar in this. Let's see if I can close this one. I'm just going to unplug just a second here so that I can get to my smaller screen. Okay. I don't know why it's at Wi-Fi offline. I'm going to tether my phone. Awesome. I think I should be good now. Cancel. I'm just going to check, make sure that I have Wi-Fi on back. Awesome. I have Wi-Fi. It's still tethered from my phone, but should be enough for this talk. All right. Awesome. Great. You go back here, ls. So I'm running the cookie cutter, and it's going to ask me a series of questions. So it's going to ask me what's the project name I want. I left the default name of Iris API. I'm going to keep the default name. You can change it if you are using the template to build a different machine learning API. Okay. I'm going to leave the repo name as it is. You can put a name for yourself. Okay, there you go. Give a description. Iris API service. Okay. Okay. You can leave it as an open source license if you want. Okay. So once you do this, you'll actually see the Iris API folder in there. Okay. So let's go back to the slides here. And then, so the next step is to cd into the folder, change directory into the folder, and then we're going to create Conda environments, and then install the packages we need, and then run the API service. We will actually run it and then come back and look at the code, because so that everybody can catch up on the environment, and then we'll look at the code afterwards. Okay. So let me navigate into the environment. Iris. Here you go. I'm just going to clear the screen just so that it's back on the top. Okay. Now I'm going to say Python environment, create environment. So I create environment as a Python script so that it works on all the machines, hopefully. So should not have a problem with Windows as well, but I'm not exactly sure. Yes?
If you don't have Anaconda, is there any other way?
Yes. So if you don't have Anaconda, in one of the earlier slides, I linked to Miniconda. So if you install Miniconda, then you can do this. But without Miniconda, you can't do this because the environment, I'm creating a Conda environment. You can certainly do it with virtual environment pip. You can totally do this. But I did not write the script for it. So you can look at my requirements, Conda, and then just to pip install -r, that file name. That should work also. No, it's not going to mess up. As long as you create it inside a virtual environment. Always create a virtual environment. Yeah, in this case, I'm using Conda environment, but you can totally do it in virtual environment as well. It's because most of the people already had Conda installed, so I kept it as Conda environment, but you can totally do it outside of Conda environment and virtual envs. All right, so once that is installed, it will tell you to activate the environment. I go back to my to my code here. So I have this way to activate the environment. Please make sure you activate the environment before you run the installation packages, because otherwise it's going to install on the default Conda. So activate the environment first. If you're on Windows, you may have to do just source Windows. I think you have to do activate NVNV. I think there is no source for Windows. I think that's the only difference. I've not tried it, but that's what I read. So I'm going to believe that. I'm going to clear my screen again. So do this. After you do this, you will see on the top NVNV on the top left corner, which means you are inside a virtual environment. Okay, you're inside a virtual environment. All right. So now I can do Python env install packages, ins, and tab completion to make advantage of it. These steps are also in my slides. I'm just copying the steps from my slides into my terminal. I'm doing it in my terminal so that you can also see and follow along. Okay? And I would love for people to follow along, because one of the struggles I had in building and deploying apps is, it sometimes works for somebody else, and then it's hard to replicate it on your own environments and your own machines. So I'm hoping, at least for some of you today, you can replicate it locally. All right? So once it's actually done, because Conda only links the packages, I believe. So it's nothing, it doesn't install anything new, which is great. Okay? So once I clear it, if you type Python, hopefully you will get this. You'll get Python 3. Okay? In fact, everybody should get Python 3, even if your default environment is Python 2, is because Conda environment, I can create Python 3 environment from even your Python 2. So everybody is on Python 3 for this virtual environment. Okay? Awesome. So after that is done, there's only one more step. One more step is to build the model Pickle, because we're going to pickle the model, and then we're going to serve the pickled model from our application, from a server. So it's only one more step here. So Python, you can copy this. Basically, I'll open the code just a second, just to show all these what this does. It's going to basically build a KNN pickle for the iris data set. That's all it is doing there. Okay, and then it's going to put the pickle in my models folder. If I put it in my models folder, it's going to put this pickle along with all the NumPy arrays in this models folder. That's really all that is doing. Okay, we'll look at the code shortly. Okay, after that, I should be able to do Python run.py. Okay, if you do Python run.py, you should get this, which means that everything is, basically all your setup is complete, your application is running, and you should be able to go into localhost 9000, and it should app is live. There is no fancy web page because this is an API service. We're not trying to build a web application here on this piece of the project. So it just says app is live, okay? So I'm going to pause here, actually, because I think they have a pause set up here. Okay. Yes, here. Okay. Pause here, because I want to make sure everybody is on it. Okay. So I'm going to pause here. There's the slides again here. I'm just going to take a quick 2-3 minutes, making sure everybody is able to go to the, install it, be able to see it. If you're not in an environment where you could see it, then definitely pair with somebody else so that you can even, watch over them. And if you need any help, please flag me down. This is a tutorial talk, so it's not a talk where you can totally flag me down and I can try to come and help you, or your neighbor can help you. Yes. Yeah. In the meantime, I'll just show you what we are headed towards. I never showed you with this. This is what we're going to end up with. We're going to end up with a web app where you can actually query, and then it's going to query your API service and get you back the predictions from your prediction. So this is a Flask app that's going to query our Tornado API service that's going to use Scikit-Learn to predict it, return the JSON response to Flask, and Flask is going to serve us back the web page. This is what we're going to end up with. But I want to make sure that everybody can follow through this tutorial. So that's why I wanted to make sure we don't run through this. Yes. Yeah, if you have any questions, please stop me. Yes. How many have it running on their locally? Okay, we have about 25%. It's not really a great sign, but it's okay. I think once this step is done, I think others will be a lot easier because I don't want to run through. If you run out of time, we'll definitely go into the other steps. But I want to make sure that we don't lose people in the beginning. And if Conda environment is a problem to you, you can directly do without the environment. So you can totally do this without the environment. You can try this directly. You can do Python env install packages.py without creating virtual environment or without creating the Conda environment step over there. Okay, 145. I'm going to slightly move on from here now, and then we will try to catch up with others in the next step. So I'm going to query this API from a Jupyter notebook. Here I need, for people who have it already installed, open a new terminal window without killing this current server that's running. Because if you kill it, then you can't query the server. So open a new terminal window, and then in the new terminal window, we're going to navigate to the same folder that you created and launch Jupyter Notebook. Okay? In fact, you need to activate the environment again. So let me show you what I'm talking about here. Okay, I'm going to open a new terminal window. Okay? I'm going to navigate to my folder. Okay, temp, PyData tutorial. I'm going to go to my Iris API. I'm going to do source env venv. Okay, so this will basically activate my Conda environment. And if you don't do this before you run Jupyter Notebook, it might complain that you might have Python 2 and this is using Python 3. So once you activate, source activate. Oh my God. Okay, source activate. All right, so let's activate this. Then I write Jupyter Notebook. Okay, so Jupyter Notebook. It'll open up this browser window with the file structure. We'll run through every file in this just in a minute after we query this. So I'm going to go into the YAML source folder, and you have a IPython notebook called API client that I pre-wrote for this tutorial. So API client, it imports request library, and then we're going to query the local API server we just launched. I'm going to run this. And you can give it one record or one observation, and it's going to come back with the predicted color or the flower value for it, and you can give it an array of records, and it's going to give you back with an array of responses. Okay, so if you have this up to this point, then you're actually a very good place. Then you have it completely configured and running on your local machine. Okay, so the steps were, I'll go back to here. You open a new terminal window. You navigate to the Iris API folder. You activate the virtual environment. That's a step that's not listed here directly, but you activate the virtual environment by doing the source activate. On Windows, it's usually, I think, just activate env. And you don't need to activate the environment. Let me say also this. You don't need to activate the environment if you are putting all of this directly in your root Conda. If you're not using virtual environments, you don't need this activate step. And then run Jupyter Notebook. If you run your Jupyter Notebook, then you should be able to run these 3-4 cells here. Yes? Yes. Is anybody up to this point? Good. I see a few nods, which is good. And I'm going to be here the whole weekend. So if for some reason in your machine it does not work, please feel free to stop me later as well. And then I'll help you. I've used Windows before, so certainly can try to troubleshoot it. It just takes some time. So in the interest of time, I'm going to move on. But yeah, even if you don't complete these steps, catch me after the talk or today, tomorrow, and we'll get it set up for you. Awesome. All right. So let's walk through this code. We actually ran through a bunch of stuff. We actually did not see what it really does in the code. Let's walk through this code. Before I walk through this code, I want to talk about what this web server does. There's one question on why Tornado. So we're going to address that question right away. Okay. So this is a slide I borrowed from Jesse Jairus, who is a Tornado contributor. I really like how he explained the slide. So I'll try to do some justice to it. So he talks about, if you go to a pizza place, a customer walks to the counter, the person across the counter takes your order and puts the pizza into the oven, and then the customer is waiting. Customer is waiting for his pizza to come back, okay? And what if the person across the counter is also waiting for the oven to cook it, and the new customer comes in, you need a second person across the counter. So for every new person that comes in requesting a pizza here, you need that many people to serve it, that many counters to serve it. Okay, that's typically how a web server does, right? A process is blocked for each request. It's not able to do multiple things at the same time. Okay, and that's really where the async process, reverse the flow where it turns the I/O blocking is what it is called, because you are waiting for external resource, in this case, waiting for the oven to cook the pizza. So the person across the counter comes back and takes the next order while he's waiting for the pizza to be cooked for the first customer. Okay, the customer, of course, has to wait. He can't go, he can't get his pizza for the next 10 minutes. But there's no reason why the people behind him cannot be served at the same time. Okay, and that's typically what an async framework, async process does. And Tornado is an async web framework in Python. Okay, and it is single-threaded. Okay, which means I'll get to one minute. It's non-blocking I/O concurrency. So it's non-blocking with respect to I/O. So if if you're going to make a database call or making an external prediction call, external API service call, in fact, you can make multiple service calls, and it does not have to wait for them to return result to serve the next request that's also come to the server. Okay, so it can do I/O concurrency. Okay, non-blocking, and that's how you can serve thousands of requests. Okay, and the word single-threaded is basically it can concurrently only work on one job at a time, right? It cannot work on all 5 requests at the same time. Just like your person across the counter, he can only take one order at a time, but he does not have to wait for an external process like this, cooking through the oven to complete for him to take the next order. Okay, so that's really what a Tornado as a web framework does for us, and it can process multiple requests, and you can certainly have multiple processes, just like how you would do multiple Flask or multiple Django processes running at the same time to serve these multiple requests, so that you're not doing one request at a time. And let me do. Okay, here we go. Okay, so what is it good for? So it's great for building RESTful APIs, although it's actually full stack. You can actually do Jinja templates. You can build complete web applications in Tornado. Okay, but it's primarily great for RESTful web APIs, which is get and post, is what we are going to use this application for. So which means you can be a great microservice, and microservices. It's useful when you have slow database connections, when you're communicating with external resources, and need to handle a large number of connections. I think we touched on all of them. So when you talk about async, I think everybody talks about, okay, so where is async I/O? Okay, so this is another slide I borrowed from Anton Karakas from his Better Asynchronous Code talk on EuroPython last year. So here's the picture he had, which is async IO is a library. And I think that's a really main difference between, where the Tornado as a web framework really comes in place. I think you can certainly do complete asynchronous web application just with async IO. You don't necessarily have to do Tornado with it, but Tornado has been around for a long time. It is Python 2 and Python 3 compatible. And they all do very similar thing with respect to using some sort of a polling mechanism. So once it sends the request to in our case, sends the prediction request, it can come back and serve the next incoming API request, and then keep polling the other request when the resources available and results are available for us to return back to continue the processing. Okay. So if you want to learn more about it, certainly go into the talk, and I think it's also posted online. All right, so let's go and look at the code. Okay, we've not been looking at the code at all. So let's look at the code here. I'm going to open a new window. You don't have to open it on your terminal. I'm going to open it here so we can see it together here. Okay, CD, going to go to temp. Anybody else? Okay, awesome. Okay, so this is our complete application environment. Okay, we have the requirements file and we have a run file, which is what we ran. The run file has only 2 lines, which is going to run the server. Okay, there's nothing additional in here. I've got notes and documentation on how on everything we're going to do right inside this app. Okay, so you go to app folder. In app folder, it calls server main.py. Let's go to server. Awesome. So in this main.py, so let me show you. Let me zoom out a little bit, okay, just to see. There you go. Okay, awesome. Okay. So in this main.py, one of the primary job it does, it creates a Tornado application. It creates a Tornado application and tells what are the URL endpoints. In this case, we have 2 URL endpoints. The first URL endpoint is our index page, which basically said the app is live when we went to the browser. Okay. Second URL endpoint is our prediction API, which is what /API iris /predict is what we did. Okay, and it is going to call this iris prediction handler. Okay, we call it handler. I think other frameworks might call it controllers. And then what's neat about it is I can actually pass in the model that it needs for prediction. So what I have here, I've created a dictionary. Okay, here I've created a dictionary, and then I'm loading all my models from the pickles into this dictionary. So the application object has all the pickled models, okay, and then it passes the pickled model into this handler when it needs to serve the request. Okay, so it's using the scikit-learn job-lib module to just load the pickle, the same way it dumped the pickle. Okay, and then I want to show you the handler itself. What it does here. And then we're going to look at the model also quickly here. Okay, there you go. So predict. Okay, so you see the predict function is being called. Okay, and in the predict function, the first few lines of code is just so that it can handle not only single record request, but also an array of requests, so that it can respond back with an array of responses when it does prediction. It creates the record and then creates this EX matrix. Okay. For us to query, and then it's yielding this blocking predict. So predict is a blocking call. So we're going to make it unblocking by running it inside a thread pool. So we have a thread pool, okay, which in this case I've defaulted to 10 in the settings file. So this thread pool, it's going to run independently on the thread, and I'm going to yield for that result. This is how Tornado makes it IO concurrency. So while it's waiting for this predict function to return result, the IO loop can start accepting a next request. Okay, and this is really the big difference between a Flask app and a Tornado app because Flask app is not that much different in structure to this Tornado app, because the next app I'm going to show you is a Flask app. Okay, is no difference, but you cannot do this yield for a blocking predict in Flask app. Okay, you will basically, that particular process will be blocked, and if for whatever reason your call takes, if I'm going to have import time, and I'm going to have time.sleep of 20 seconds or 10 seconds there, okay, If it's a Flask app, it's going to wait for 10 seconds. It cannot accept any new request. That's the main difference there. It's not just both frameworks are going to take the exact 10 seconds for the primary request. But in Tornado, it doesn't reject other requests that's going to come to the server. It's going to also process the next request that's going to come to the server. And that's a big difference, or primary difference between the async I/O processing that the Tornado enables through coroutines. And the same coroutine is the process how async I/O module also does a few things. Okay? Are there any questions on this? Yes? No, I don't think so. Okay, again, I'm not sure if I'm qualified to say it's not possible. I have not found a way to do it, is what I should say, because I have not done it. I don't know if it's possible. I don't believe it's possible because those are blocking frameworks. Or when I say blocking, you have to create multiple processes for handling multiple requests. So here, the same process is able to handle multiple requests. That's the main difference between those two things. So, of course, you have thousands of requests coming to a Django and Flask app as well. But then you are handling it by putting a load balancer and creating 100 Flask processes ready to accept requests. But there is an upper bound to the 100,000, right? There's only 100 requests at a time you can process, 1,000 requests at a time you can process. And the way you solve that problem, in a Django and a Flask app is this. You make sure that these O1s are efficient. They don't take 10 minutes, they take 30 seconds. So you make sure each process does not take that much time, but sometimes you don't have control over them. If you're going to make an external API call, it can take 2 minutes, and then and on the way to I think the way deploy and the way people manage that process is having many workers being able to process and be available to accept incoming requests. But there is always upper bound to how many workers you're going to have because you're going to set it up, but you can certainly auto scale and do other ways to manage that. And the difference in Tornado is a single worker can be more efficient, right? While he's waiting for the pizza to be cooked, there's no reason he has to be idle, right? No business runs that way, right? So there's no reason our web process has to run that way too. So that's the big idea in the async process. And I believe in other languages, Node.js or I think Akka and other frameworks do similar things. Okay. Thanks for the question. I think it's a good one. All right. Let me go back to the code here. Okay. So you see that there is no callbacks here. We are not doing any callbacks. We're just yielding it, which is just Python yield from generator. It's just almost like a yielding from a generator module. That's really what you're doing here. Okay. To move this code up just to make sure. And there's not that much code here because there's no reason code has to be here because it's just calling the machine learning Pickle to get me the results. There is no Scikit-Learn module building inside here. Okay. And I want to show you one other file here is you can certainly browse through other files. These are not that interesting. These are just saying how many thread pools I want, like how many concurrent requests I want to process for that API. I can certainly bump it up because these are lightweight threads. I can have 100, as much process or memory I have, honestly, in my machine. I'm using a T2 micro AWS instance for this deployment, and nobody's going to eat my API, so I can, I don't need 1,000 threads on this. Okay. And what else is in here? Okay, exception folder, exception file, just as a listing of exceptions. I found a project that actually does this very nicely where they have all the exceptions in one place. So I adapted it here. And then the base handler is one place where we have this respond. So this is what basically creates the JSON response. That's why when we go to our Jupyter notebook, you get the status code as well as data in a JSON result. There are lots of libraries that try to standardize how you format your JSON results. You can even put a schema on top of it if you wish. But for this application, it was not necessary. So I just have the status and then the data. Those are the only two properties that comes in the JSON response. And data is an array, is because you could actually have you can pass in multiple observations or multiple records, and it'll return you back in the single request array of values. Okay. Tornado can do a lot more than this. Can in fact yield parallelly, yield multiple features in parallel. It doesn't have to do the, so in this application, I didn't have a need for it, so I don't have it. Okay. Other than that, there is nothing else in this application, honestly. Let me also show you my build model code, which we just ran, but we didn't walk through. So this is basically building this is all the code that is, okay? So let me move up quickly here. Oops. Okay, so here I'm loading the iris data set. I'm building a k nearest neighbor KNN model, okay? And then I am pickling the model through joblib. I'm dumping the model into a pickle file, and that pickle file resides inside my common models folder as a model.pickle, and then it's got all the NumPy arrays associated with it. Okay? And that's all this app is doing, and that's all your app should do also, because you're writing just a wrapper service on top of your Scikit-Learn model. So all the hard work should be inside your feature engineering, your pipelines, all of the other places. In this, here it should just load the pickle, run your model, and then return the result. That's really all work should be here. And that's why Tornado makes a great framework to just do that layer of wrapper on top of it. All right, how are you doing on time? Good. Okay, great. I'm going to slightly move on this. And please feel free to stop me afterwards, ask questions. Yes? Sure. Yes. Yeah. No. Good question. Yeah. So, it's again, it's like. So the question is, what's the difference between companies like Yhat or Dado or other companies which offer model deployment versus rolling it on your own? I think it's the same difference between you deploying it in AWS EC2 versus using Heroku to deploy things and manage things, right? So, in this scenario, you will have to, you're rolling up your own web app as API service, which means you are responsible for logging it. If you need to scale it, you're responsible for scaling it. But if your environment already includes deploying your own web instances, right? There is, you may or may not have a need to use their services. But if there is but they're all great companies, right? So, and if that service gets you there faster, cheaper, you should definitely do that. This is completely, you can roll it on your own. There's nothing magic behind it to deploy your model is what this is trying to show you. Yeah. That's really all that is trying to show you. There is no magic in deploying the model. You can get it deployed very quickly, very easily. But there may be instances where they will do something better, faster. They can alert you. I'm sure there are ways to do it. But yeah, cool. Yes, question. I believe so. I have not had a problem of 10,000 requests per second to say that, but if I if I listen to any Tornado tutorial, any talk, the first thing they talk about is they choose Tornado because it is highly scalable. It can handle tens of thousands of requests. It's open source Facebook project that they acquired from FriendsFeed, and the main reason FriendsFeed did this is because it can handle thousands of requests concurrently. Okay, and Tornado's main, I guess, rise to fame is that it is the only Python framework, at least at the time, to do this multiple thousands of requests per second. It does not compete with Django with respect to features on all the module plugins and all the other stuff. The only thing it competes on is the I/O concurrency. If you have blocking I/O database queries, if you have external API services, then I'm not sure if other frameworks will be able to serve you that well. Good question. Yeah. Yes, you have a question there? Yes. Can you use the microphone there?
Oh, sorry. So yeah, if you wanted to mix and match the two, so you had like a web application which needed a lot of data entry and retrieval from tables, so like list views and things that Django gives you. But you also have machine learning. Would you recommend using the two APIs on different, like the two frameworks with different APIs?
Okay, let me address that by just saying Tornado doesn't do anything other than just serve the request. Tornado does not have anything to do with machine learning. It's all done by Scikit-Learn here. Tornado is a Python program, if you think of it, that loads that basically loads the Scikit-Learn model as a pickled file, and then queries the model and returns the result. And the same thing can be done by Flask. It can be done by your Python script. You don't even need a framework for it. What Tornado allows us to do in this instance is, if your prediction query takes longer, then it's not going to, it can accept a second incoming request. So it can do multiple things in parallel when it's dependent on an external service. Here, the app doesn't do anything. The app is actually, if I look at my app here, Handler, it's a good question because that's the core of this talk. So thanks for asking that. So app actually doesn't do anything. All the app does, the app's purpose is to run the prediction query and return the prediction results, right? That's really all the app is doing, which means the app is dependent on this pickled Scikit-Learn model, okay? With the pickled Scikit-Learn model, okay, through our infinite pipelines that we have inside the model, feature engineering, that it takes us, let's say, 3 seconds to do one prediction. Let's say I'm going to simulate this here by saying import time and time.sleep, okay? Time.sleep of 3 seconds for every query, okay? Then other frameworks will not be able to accept a second request by the same process, okay, or thread, okay? Whereas Tornado, because of its non-blocking nature of it, it can basically, while it's waiting for the response from the Scikit-Learn model, it can release the I/O loop to go and serve the next request. Yes.
I'm sorry, where is this code located?
Oh, absolutely. It's in fact, if you go to the if you go in the slides and go in the cookie cutter, and then if you actually go to that will basically take you to. Oops. Give me a second here. Okay. Here. So that will basically take you to my GitHub handle, and that's a cookie cutter app for it. And then if you go in there, there'll be it's all inside there. Yes. I don't know. I don't know Falcon. I'm going to move on because honestly, I don't want to talk about Tornado as much as this talk is about just deploying API services. Because there's, and secondly, I'm not a Tornado contributor, so I don't want to misstate some things. Awesome. So we walked through the code here. So so let's reiterate that. Build model pickles the model, and then our app itself just serves the model. That's all it does. Okay. Let me move on to the next step. Okay. We're actually doing good on time, so we should be okay. We have 30 more minutes at least. Okay. So let's add a web server that uses this API service. Okay. So here I marked it as third terminal because I'm expecting that you have a terminal 1 where your Tornado app is running, and you have terminal 2 where Jupyter is running if you need to, if you want to query from Jupyter. If you don't have it running, it's okay. Okay. And in third terminal, I'm going to create a web app. In this case, I'm using Flask. Okay, because Flask is an awesome framework to create simple web apps. Okay, so I'm going to address this part of the puzzle here. So we already did what is in the gray box. What's in the gray box is what we built and then launched it on our local machines. we're going to do similar process to build and launch this Flask web app. Okay? And if I run through a little bit faster and then you cannot follow up in your code, please feel free to stop me also. But if you have any questions, please ask me those questions. Okay, so let's go on to the next step. So a similar process, I'm going to do a cookie cutter and then pull this app. So this time, the only difference is the last one is not called API, it's called an app. So I'm going to copy that. Okay, escape. Okay, I'm going to copy this. Then go to my terminal. I'm going to open a new terminal, which is this. Okay, I'm going to make sure I'm not inside the Iris API folder. I need to be at the top level because I don't want to create this, I don't want to create this project inside another project. I want the top level. And then I do cookie cutter. Let me just make sure I have the right zoomed in. Okay, so it's going to ask me a series of questions. And I have the default app name as Iris app, which should be good. Okay, I'm going to leave everything default. And then let me show you what that folder looks like. So now the folder has two projects, in fact, in there. There is an Iris -API. There is Iris app. And Iris API is what we launched just a little while back, which is the Tornado API server serving Scikit-Learn model. And then Iris app is a Flask app, which we are going to launch now. And that's going to talk to our API server. Okay. Let me go into the slides here. And it's the same process I have. So you cd into the folder, you create the environment, activate the environment, install packages. I'm really sorry if people have trouble creating environments on different machines. You don't need to create environments. You can directly install as well. Or if you want to, we can work together after the talk or later in the evening or tomorrow and fix that. Okay, so I'm going to go into this Iris app. Okay, I'm going to cd into Iris app, and I'm going to do Python environment, create environment, just the same process. Make sure your virtual environment is not active because we're going to create a virtual environment for the web application. And the reason I'm being specific about creating specific virtual environments is because when you deploy these apps, you don't want to, you might have in a single web server multiple apps running. And if you don't have virtual environment sandboxing each app, then they may have conflicts in the packages. Not immediately, but eventually. Okay. Let me activate it. Source activate, environment, virtual environment. Okay. I'm going to clear my screen to get to the top of the screen. Okay. So next step is to run the packages or install the packages. I'm going to say Python environment install packages. Okay. So this will basically install Flask primarily, and then it's done actually. So it's installed Flask, and then I'm using a Flask forms, and that's Jinja templates, and that's really it. There is no nothing else in there. I want to clear my screen again. And I'm actually done with my web application. I'll show you the code also, Python run.py. Okay. Now it's got a Flask running. I go to my browser, I go to my local host, 5000 in this case. That's where I launched my Flask app default. And you will actually have, let me zoom out, it's too much. Okay. So you will actually have this Iris app in there. Let's query it, and then we'll look at the code. Okay, 2315, I don't know what that is. This is Sentosa. Okay, so I'm able to query it. I can query it multiple times. It's going to come back and give me the same result, of course. Okay, so you can change the query. So now our web app is talking to the API server, and we're going to look at the code right now. Make sure that's what I had in my slides. I'm not running through any of that. Okay, so we had this, did this. We did this. All right, and then let's open the code. Yes, awesome. Go. Okay. Oh, I actually have the code already open here. Great. Here. So this is the API. I'm going to close these ones so that we are not looking at the wrong server. Cool. Okay. So this is the Flask app. Okay. This is also a microserver or micro web framework. I like it a lot for small projects and also big. So again, this is just going to run the application, and then the application it's importing from here. It's creating a Flask object, and then it's setting a basic logging module config, which you should use, and here, if I go to my views.py is where the routing is. It's got two things in here. One is the form that it uses to give you the top level form. And second one is it validates the form and then gets these 4 flower values that you entered. And then it uses the query iris API. Query iris API and then gets the result and returns back the form. That's really all it's doing. And when I go to my query iris API, it's actually using request module, Python request module, to make a call to our URL with this JSON payload. And you would be familiar with this from, I'm going to show you this one, this. This is exactly the same code that we wrote in Jupyter Notebook. Okay? So you are creating a payload, which is basically all the features that you need for your model, or at least in this model. And then you're making a post request with that URL endpoint and giving the JSON payload. That is the same code that's here. It's just a little bit of extra, error checking to make sure that we are getting a response code correctly. Okay? And in my config.py, I am telling it where my API server is located. When we did the Flask module, we did not run the build model.py. There is no model here. It does not even know Scikit-Learn. In fact, Scikit-Learn is not even installed here. It's not even part of the requirements. Okay? This is a complete web app. Okay? And this could be your totally non-Pythonic web app as well. It could be Ruby or any other web app. Okay? Using the same sort of API service to talk to your machine learning API service. Are there any questions at this point? Yes?
So why do you need Flask? Why don't you just build it from
Yeah, totally. I could have, but I want to show that you could access from any other web application. So I want to just show that you could access this API from a non-Tornado application. You don't need to, it doesn't have to be a Tornado. I don't want people to walk away feeling that, oh, this is all Tornado ecosystem. I want to just, people walk away saying that this is a microservice let me back up also in saying, and also I want to back up and say that you could have done this in Flask as well. You could have done this in Django as well. Right? You could do the same process of wrapping your Scikit-Learn model into a Flask app, into Django app. That totally works. Right? I'm just showing you how I have done it in the past and why I like it to be the good fit for this kind of a simple service that does not have any templating. In fact, it does have full, it is fully featured, but you don't need to, if you are a data scientist, I guess, or some sort of a machine learning engineer, where you're just building models and you're trying to, all you want to do is to make this model accessible to other ecosystem within your enterprise. Then, that's really all this app is trying to do there. And then here as an example, I have created an app just so that we can demonstrate that process, the end-to-end process of it. It's a good question. Yeah. Awesome. Great questions. Okay. Cool. All right. So any other question? Great. We are actually doing good on time. Okay, let's deploy this on AWS. Okay. For this step, I'm not going to have you follow along with me. I'm going to do this deployment here. I have it all documented in the notes section inside the GitHub as well. So if you want to do it yourself afterwards, I highly encourage it. Do it, and then catch me doing the conference outside, and if you have any issues. But I want to show you to how easy it is. Okay. So I'm going to EC2, my account, I guess. Okay. So I created an image just so that I don't have to install Miniconda on it. That's all. That's why I have this image. Okay. And then I launched from this image. So from this Miniconda image, and if I did not, if I had more time, I would have created from scratch. Okay, which you could also do if you. Let me show you that, and then I'll come back to this. Okay, we're going to go to instances. I'm going to launch an instance, and then I'm going to, let me zoom out a little bit just quickly here. Okay, I'm going to choose a Ubuntu 14.04. You can certainly choose any sort of a Linux flavor that you like. Okay, Linux, Ubuntu 14.04. Okay, I'm going to choose a T2 micro, okay, which has got a 1 GB RAM, which is more than sufficient because it is not memory bound or doing anything complex over here. Okay, and then you go to the next step, you choose how many instances you want, and then you go and launch your instance. Okay, that's the process. So I'm going to use my AMI here just because I have a couple of packages installed on it, and that makes it process go quicker. Okay, it's the same T2 micro. Okay, I'm going to go here. I want only one instance. Okay, 8 GB is more than enough. I'm going to say Iris API PyData service. Okay, okay. Next, I'm going to choose an existing. All I need to do is to open up port 80. Okay, you should do SSL, which is 443, but you could do SSL through load balancer of AWS as well. You don't need to do it through here. I'm going to choose 80 and 22, and I'm going to launch my instance. So I'm going to choose my key pair that I already have, create a PyData, launch the instance. Okay, so once this is launched, okay, let's go back here. Once this is launched, it's got nothing other than 2 steps. I'll show you what 2 steps it is here. Okay, deploy here. These are the only steps that's already been done. These exact 5 steps on top of a bare bones machine. So I updated the instance, I installed Git on it, I installed Miniconda on it because I don't need a full Anaconda for what I'm trying to do in this project. And then I basically added it to my bash profile or bash RC. Okay, that's all has been done. We're going to do rest of these steps. We're going to do rest of these steps to basically install the app, deploy the app, and serve it on the web. Okay, so we should be able to do it in 10 minutes. Okay, let me go back here, and it's actually initializing. So if, in the meantime, if you have any questions, because we are almost towards the end of the slides itself, which is good because we want to run it and demonstrate it here. Awesome. So we have an IP address. Let's go and log in. Okay. Open a new terminal. Okay. Go to SSH using my PEM key for PyData. Okay. It may still be initializing, so it's not ready for me to log in. It may not have the still initializing. Okay. And I want to leave it here just to see. Oh, it's up, done. Great. Okay, so it's got nothing else on it. So I'm going to walk through my deployment steps to make sure I got it right. Okay, walk through my deployment steps and then just do it. Okay. So I'm going to clone the repo now. This is this is my. So if I let me show you what this repo really contains. Just to. So I'll go back to my repos here. This is the repo. So this repo is the Iris API that we just built and walked through. Okay, it's got the same folders: API client, build model, and it's got the app folder which contains the Tornado app. Okay, so let's go here. But because I'm here, I'm just going to copy this from here. Copy. Git clone. Okay, that's going to clone this repo. Great. Clear the screen, get to the top. Okay, great. So now I CD into this. These steps are exactly the same steps that we walked through when installing it locally. I'm going to create the environment, Python environment, create environment. That's going to create now a virtual environment or Conda environment for me to use. Great. Then I'm going to activate it, source activate. Okay, done. I'm going to install packages, Python Python environment install. Okay, there you go. Okay, so same steps. Okay, it's going to install all the packages. This might take a little bit of time. Okay, so once this is installed, what we're going to do next is this. I'll just show you that while it's installing. Okay, what we're going to do next is we're going to put the process, the Python process, inside a supervisor. Supervisor is a process manager. So supervisor can actually manage multiple processes. It can auto restart the process. It can distribute. You can keep multiple processes running. It can also log our processes. So it's a great way to run your Python applications. So that's what we're going to do next. And once we run it in supervisor, our app is actually live at that point. Okay. So once this is installed, time, good. Awesome, it's done. So let's go, and then the next step is to actually install supervisor. Let me first run the program just to make sure it's running. It's not going to run actually. I need to build my model. If I run it, you will see it. It says the models file doesn't exist because I didn't build my model. Let me run it. Let me build my model, Python, src, build my model, which is going to Pickle and build my model. Now I should be able to run my application. Great. But this is not how I want to run it. I'm going to cancel it. Okay. I want to run it as inside supervisor so that it can manage and then start my processes. So I'm going to run sudo apt-get install supervisor. Okay. So it's a process manager. You can manage multiple processes through it. Okay. So now I want to add a supervisor config. Let me go here. So this is where the difference between Ubuntu versus CentOS is where your config files might be. So you have to be careful if you're using a different version of Linux and not Ubuntu version to put your files in. Okay. So I put this in. I'm going to go to insert mode. I'm going to basically copy this and we'll talk about it. Paste this. Awesome. So all I'm trying to say here is I'm calling the Python inside my virtual environment. That's what that is. Okay, in my home Iris API. I'm calling the run.py. Okay, I'm making sure debug is false because it's running as API service. And then I'm setting it to port 80. And that's how it's able to serve on HTTP port. I'm setting the port to 80. Okay, I'm running only one process. You can run multiple processes if you want. Okay, and that's it. I'm setting where the log file should be, standard error, standard out, and I can set a Python environment variable here. Okay, and then I save this, right quit, and then I just need to set my supervisor reload, which basically reloads the config, and I can monitor my status of my running processes. So it's starting. Great. Okay, running, great, awesome. So now it's running. So we can take our IP address that we just created in EC2. Let's first test it in Jupyter Notebook, make sure that Jupyter Notebook can see it. I'm going to just replace the local host with the IP address. So let's just set that. It's actually, it gets the result from the IP address. So it's actually going to the AWS machine, querying it. I can also go to the AWS machine directly here, and you will see app is live. Okay, that's all it is. You can't use the browser for querying the API there. And then one more thing we want to do is also change it in our Flask app. Let me go into my Flask app. In my config, I go and remove the local host in my Flask app, which could be hosted anywhere. And then I change it to this API, save this. Okay, and then it is in debug mode, so actually running, but I can also cancel it and then rerun the Flask app. Then go back to my browser, and then I can give this, and then it's actually going to get the results. And that result is coming from our API server, not from our local host, because that's the config uses API server there. So you can certainly DNS it to your own domain names and stuff like that, or you can do other things. And then I have only one more slide here, and then we'll take more questions. Yes? My Flask is running as open or local host, but my the Tornado is running in AWS server. So my Tornado is not running here. I can even cancel it. Right? There's no Tornado running here. This is also only the Jupyter notebook that I can kill it if you want. And then this is the Flask app. Flask will still, of course, get it, right? So Flask is running locally. I have not deployed the Flask app. I only deployed. It's a good question, actually, because can definitely be there's a confusion on this, the way I have represented it. So Flask is running locally, but the API Tornado is deployed. Yes. Good. Yeah, thank you. Thanks for the question. Yeah, great. Yeah. So one more slide on this, actually, which is this one. Awesome. So what we did is what is on the right side box here, supervisor process, and we put Tornado processes inside to supervisor process. That, for the most part, is enough to serve it over HTTP, okay? Particularly as a microservice, okay? Because you're not serving static files, you're not serving anything that needs to be cached, okay? But if you want to put a load balancer in front of it, like Nginx, okay, or even AWS load balancer if you want, you can totally do that, right? That's something I have not shown because I didn't have a need to do it in my own projects as well, but you could also do it. But if you do with Flask app or any other app, you must need that because you have to serve Flask app through gUnicon or USG, and then that needs to be served through Nginx. You could not have done just through the process that we did that easily. So I believe to be. Okay. That's really all I had. I think we did good on time, I think. Yeah. So if you have any questions, please feel free to ask me. And then, yeah, if you want to add anything to what has been said also, please feel free to talk about it.